So we said RAG, you're not affecting the LLM at all. It's kind of on its own. RAG, we're just, like as the name implies, augmenting the prompt. We're giving it more context, and we pass it along to the LLM, and the LLM is the same LLM, with or without RAG. With fine tuning, we're actually going in and internally changing the model. We're changing the weights of the model, would be the word that we would use there. And so it's going to affect how that model processes input and how it produces output.
You are listening to Stories from the Hackery, a podcast about the students, alumni, and community members that continue to shape Nashville Software School. NSS is the nation's first nonprofit coding bootcamp, where anyone with aptitude and motivation can gain the skills needed for a career in tech. For more information, visit nashvillesoftwareschool.com.
Hello, and hopefully welcome back. I'm John Wark. I'm the founder and CEO of Nashville Software School, and I'll be one of the two of us on this episode of Stories from the Hackery, where we'll continue our conversation about generative AI. And with me will be Michael Holloway. Michael, you want to introduce yourself?
Yeah, thanks, John. I'm happy to be here talking with you today. I'm Michael Holloway. I'm our lead instructor for the data programs at Nashville Software School, and I teach our data science boot camp as well.
All right. So our topic today relates to other ways that we're going to take advantage of LLMs other than using them as a chatbot, and in particular using what I'll call the public chatbots. So ChatGPT, Claude, Google Gemini, all of those kinds of tools. So using these hosted public LLMs via their chatbot interface, that is sort of how a lot of people are still coming to understand LLMs in that context and using them as a personal productivity tool through the chatbot. Our belief is that over the next few years, that actually a lot of the consumption by organizations of LLMs will be LLMs that we use through something other than their public chatbot interface. And that may be using a ChatGPT or Claude or something, but putting it behind a software interface that we create, or it may be other forms of embedding the LLM in a broader application. Michael, maybe let's start. We've got sort of a range of different techniques that we're going to talk about, ranging from relatively straightforward to implement. Using tools even that the public chatbots provide us. They generally provide us with an API so that we can access them other than through their chat interface. So for some uses, that may be sufficient. And then there's more advanced uses. But let's talk about that first sort of use case, which basically provides us a way, to, I don't know if intercept is the right word, but to have some software between us and the API that we write that intercepts the user's prompt and then maybe tailors it, expands it, adds on to it, so as to implement a more focused or tailored or effective or consistent prompting strategy when using the tool for a particular problem or use case or whatever. So we've kind of called that prompt engine, we've called that, putting a wrapper around the LLM. but it's basically predicated on extending the user's prompts. We've not really talked in a lot of detail about prompt engineering, I don't think, in our podcasts up to now. So
Yeah, it came up, but
right. So maybe you could talk a little bit more about prompt engineering, because if we don't understand prompt engineering, then it's hard to understand how this using this wrapper to talk to the API works.
sure, yeah. So prompt engineering is I think a critical part of effectively interacting with a large language model. So prompt engineering is in some ways giving more explicit instructions to the large language model as far as what role it should take, what sort of response you're looking for, maybe the structure of the response that you want back. It can even involve providing additional context to the large language model. So these large language models, in their name is the word large. They've been trained on a large amount of text data. They're often trained on a big chunk of the internet. So they've seen a lot of general text from all over the place. And so if you just ask them a question or prompt them or request a particular output, what you get back is often going to be pretty generic. And so if you just go in and say, write me a poem, or write me a recipe, or it's gonna give a very generic kind of response back. And so one thing that prompt engineering can do is it can change the style. You can be more specific about the style, the structure. It needs to be this length. It needs to be 3 paragraphs long. It needs to be written in this voice. So you are a lawyer. You're going to help me review this document, and so that will change the way the response looks, the way the response sounds. It doesn't necessarily make the large language model smarter, but it in some ways it focuses the attention of the large language model so that the result is maybe more applicable or more tailored for your particular use case. And so the idea, if you're working with an application and your user is going to type in a request, then you're going to take that request and you can add on some prompts, either in terms of how the large language model should act, like what role it should take. It might be something about the structure or what resources or how it should be thinking, what that response should look like. And so that's kind of the most basic way that you can get more effective results in incorporating an LLM inside of another application.
And that application that we're going to build to talk to the API of the LLM, that's just a normal application. Any software engineer, with the appropriate programming skills could build something like that, right? I guess we maybe should note too that the API itself, our API calls have, if you look at the ChatGPT API specs, for example, you have some controls just in your API call that can also tailor or constrain the context within which the LLM's working, which you don't really have direct access to when you're using the chat interface, right? So we can set its, sensitivity or, the way it responds to certain kinds of things.
You can control the temperature. You have some additional parameters that you don't have through the chat. So temperature is a way. Large language models. In our last conversation, we mentioned how these things are they're random outputs, or it's generating text It's not completely random, but it's using probabilities to figure out what is a probable next word to generate, and so you can have a little bit more fine-grained control over that aspect, how it's generating text through the API.
Right. What the probability hurdle, in a sense, has to be in order to
Mm-hmm.
to select the next token, maybe. Right. I think that's the way it works.
It does, yeah.
Okay, so this is something we can build, which allows us to use some of the features that the LLM itself provides us via its API, and the different LLMs have different features like that. So you have to it's going to be based on which LLM you're using, right?
Exactly.
And I can basically embed prompts into this as well that we're going to add to or use to control maybe a hidden conversation with the LLM before we give a response back to to the user. So we could hide something that goes beyond like a one-shot prompt. We could hide the conversation in our code, right? If I'm understanding how these things work, right?
Exactly. Yeah. You can when you're calling that API, you can include kind of the conversation up to that point. You can also provide system prompts that are essentially you're acting in this role. You're a helpful assistant, or if it was reviewing legal documents, you are a lawyer, or you're acting as a lawyer to provide advice on documents that the user is going to provide. So you essentially set up the role of the LLM through that API.
Right. And so so this is this is something that organizations who may want to have set up a specific capability for their staff to use to be able to query LLMs to help them with a specific challenge, reviewing new purchasing agreements, right? Where the LLM works fine. We only have a couple forms of purchasing agreements, but we do want to put some constraints around it, some context, that we can feed it every time we do a prompt. And our volume's not so high that the inference cost of using a public LLM is going to break our budget. So, we could wrap something like that around. If I need a lot more data, right, for the problem I'm trying to create, that can push us out of using this sort of simple wrapper, this sort of prompt engineering technique, I guess, into using something that is conceptually similar. I mean, it's this, it uses the same idea of working external to the LLM. We don't have to tinker with the training of the LLM, or anything. But where we start to use a technique called retrieval-augmented generation, or RAG, as another way to constrain or tailor or adapt an LLM for a specific application, specific organization, what it may be. So tell me some more about retrieval augmented generation. What is that? And that is external, right? So how is that different than fine tuning the model itself? What kind of skills do I need to do this? Talk to me a little bit about, first of all, just what is RAG?
Yeah. So for RAG, it's as you were describing it, it's sort of the similar idea where a user request comes in. We're going to take that request and we're going to modify it in some way before sending it to the LLM. But with RAG, that modification step is a little bit more involved. So this would be a case where you would have some sort of external repository or database containing it could be containing a lot of documents. So if you had the purchasing agreements, maybe you have past purchasing agreements saved, other references, other sorts of documents that might have useful context to answer the question would be in this external database or repository. And with RAG, the idea is the question comes in, and then we're going to go through this database and we're going to search out potentially useful context. We're going to pull that out and we're going to send that context along with the original question to the large language model. So given more context, the large language model can provide a better answer. And so what the RAG setup does is it is pulling that context to assist the model so it can come up with a better answer. That retrieving the documents is external to the LLM. It's independent. It's a step that's done before you talk to the LLM, essentially. So this system is just about pulling from past purchasing orders, maybe pulling from an internal knowledge base, something that the LLM has not been trained on, maybe doesn't necessarily know about. It's a way to overcome some of those limitations of a large language model. Large language model only knows about what it was trained on, what was in its training data. And so if you have an internal knowledge base that language model doesn't have access to, doesn't know about, it's not going to be able to answer as effectively if it had access to that information. And so we're kind of going in there, pulling what's needed to help it develop a better answer.
So it's a way that in the broadest possible sense, we can train it in a generic way on the specifics of our organization and how we do purchasing, not just sort of generally, or how we do this kind of contract, or how, whatever it is, right? Or, our specific editorial rules for creating content, which are different than general English grammar that the LLM knows, those kinds of things. It's not training sort of in the LLM specific sense where we train the LLM, right?
It's not changing the model itself. We're not changing it internally. It is just kind of focusing the way that it's going to generate its response.
Right. So we've got this external database. The model's got its internal database. It's usually not referred to as a database. We talk about the weights of the model, but it's all the data that's extracted during the training process or created in the training process. Yes, and we're leaving that alone, but we're using this external data and then passing the appropriate bits in as we do a prompt. So are we talking about using a database management system like our normal SQL database management system for these RAG applications, or are there sort of some specialized tools and things we would use to build a retrieval augmented generation capability?
Yeah. So it could be it's really anything that can pull relevant context. And so you can use things like Elasticsearch is designed, for doing that exact thing. You have a query and you're going in and trying to find relevant documents. But what people are often using are what are called vector databases. And so the difference between a vector database and something like a traditional SQL database is that the vector database is storing embeddings of text, or it could be even images or other modes. And so what these embeddings are, so a large language model, you're interacting with it with using text, but what the model sees, how large language models or other models that are working with text, they think in numbers. And so an embedding is basically just a numeric representation of a block of text. Could be a sentence, could be a word. So taking the original text, converting it into a numeric version, and an interesting thing when you're converting to a numeric version, then most methods you end up with a numeric version which actually captures semantic relationships between words or sentences. And so what that means is it's capturing the meaning, not necessarily the exact words that are used. And so if we're looking at an example of this, like the words dog and puppy and pooch, those all have very similar meanings. They don't necessarily mean the exact same thing, but if I'm looking for if I'm typing in, I'm trying to find the best dog food or the best food for my puppy, then that basically means the same thing as I'm looking for the best food for my dog. But if I'm doing kind of a keyword-based thing, puppy and dog look quite different. But these embeddings can actually capture the fact that dog and puppy have similar meanings to each other. And so the power of these vector databases is that they allow for semantic search. So you can search by meaning, not just searching by keyword. And so that's very powerful, and it allows you to uncover potentially useful context in a way that you're casting sort of a wider net or a somewhat different net than just looking for specific keywords, because you can actually look based on.
So we're basically, in a sense, pre-processing this data in a way that helps the LLM focus its generative work in a more, contextually relevant way, which will drive the quality of the response we get out, right? And as I understand it, in a lot of situations, that will help alleviate, not all, but it'll help alleviate the hallucination problem relative to a particular use case or problem domain. It'll help alleviate some of the challenges we see with the totally general purpose trained foundation models.
Absolutely. Yeah. Hallucinations are a huge problem, and one that it's not going to be solved, at least not with the types of models that we have, because they have that randomness in there, and they're trained to produce plausible text, not produce factual text. But if you're working with a general purpose model, then it will tend to try to fill in the gaps when it doesn't know something. And so that's where you can end up with incorrect information, something that it just made up because it didn't know, it didn't have the right context. And so by providing that context, that can help mitigate hallucinations, but nothing is guaranteed to remove hallucinations.
Right, but it can lower their frequency, that the incidents, it can improve the quality. You're not going to get the 5 nines dependability, but you can certainly raise it through retrieval-augmented generation. Yes. So, all right. So we've talked about the vector database systems as potentially one of the sort of new tools that we haven't historically used for sort of general purpose kinds of things that we would use maybe to implement retrieval-augmented generation. I believe there's both open source and vendor provided vector database systems. Is that right?
That's correct.
Okay, so we could find open source examples out on Hugging Face again, but there's also some vendor specific, and also people are adding this vector capability to traditional relational systems, right? I think I saw that Postgres
Yeah, you can work with vectors using Postgres.
So I'm guessing we're going to see that added to some of the other commercial database systems.
Almost certainly, yeah.
Yeah, it's hard to believe we wouldn't. So, retrieval augmented generation, I think, is also ways that, sometimes we read about using knowledge graphs with an LLM. Retrieval augmented generation is one of the ways we could implement we could take a knowledge graph that we have or build one, which is going to sit outside of the LLM, but take advantage of it, and then again hand off the embeddings to the LLM. Is that right?
That's right. Yeah, and if you're working with a vector database, the embeddings just serve to find the context, but then we hand it back as actual text to the LLM. The LLM is gonna take that. But then, if you're working with a knowledge graph or whatever your data source is, you would be utilizing that to get the context and then take that in text form. You would usually want to you would take that and then sort of set up a prompt that has the context in there, has the question. You might have additional instructions to the LLM. Something else that a lot of people are doing nowadays too is they'll pull 5 or 10 or potentially relevant passages and then rank those or kind of re-rank them based on the relevance to the question. So there's a lot of different algorithms for, okay, we have the context now. How should I present it to the LLM to get the best results? So for a while, LLMs were running into the problem of it would lose things if it was in the middle of a long context passage. It would do better if it's top or at the bottom. And so the thought was, well, if it does better if it sees something at the top or the bottom, then let's take the most relevant passages, or what we think are the most relevant passages, and we'll put those at the top and the bottom, and we'll sort of put the lower relevance documents in the middle where it doesn't, or it's not as important if it loses some of the context there. We just want to make sure it can see and utilize what we think is going to be most useful for answering this question.
Right. Okay. All right. So vector databases, it's one of the tools we use. I know there's some, frameworks or, pre-built applications that have started to become available, for doing a retrieval augmented generation. I know you can get some of those out on Hugging Face. I'm sure there's libraries on GitHub as well, but I think LangChain is one.
LangChain is a very popular one.
Yeah, very popular, and it's been around, for quite a while. So it's, relatively speaking, got more usage history. None of this stuff's been around all that long, but LangChain is one example of a tool set or an application that's open source that I could use to build my own retrieval augmented generation, right?
Yeah, essentially, you can plug in what is my data source. Often it's going to be a vector database, and so which vector database am I using, and then you can plug in which LLM am I interacting with? Am I going to go through the OpenAI API? That you can do that. Am I accessing a model through another channel? And so it has kind of the middle piece, and then you just hook it up to data sources. You can even do some prompt engineering or setting up prompt templates through these frameworks, and then you connect it on the other end, and it can take the response back and provide it back to you in a nice format as well.
If you're enjoying this episode of Stories from the Hackery, subscribe to the show on your preferred streaming platform so that you're notified when new episodes are released. Support NSS in their mission to create opportunities for individuals to gain skills for high-paying tech careers who are financially disadvantaged or from underrepresented groups in tech. Visit nashss.com/give to donate to the scholarship fund and learn more about other volunteer opportunities with Nashville Software School. And now, back to our conversation with John Wark and Michael Holloway.
So in terms of skills that an organization might need to do this work, the technical work of building this sort of retrieval-augmented generation capability to go with the LLM, again, we're working external to the LLM, so we don't have to understand the machine learning associated with training the LLM itself. This is all, for lack of a better term, standard software engineering techniques, as I understand it.
It doesn't require a whole lot of specialized knowledge.
Yeah, you have to learn your vector database like you would any database you're going to use. But if you've already got relational skills or you're already using Postgres, for Pete's sakes, that's going to be a relatively small step. And as I understand it. So I can use my existing product developers. I can use my existing application developers as staff to do this work. We don't need a lot of specialized help. We got to understand our data. We got to, there's a lot of things you have to understand and do well, but I don't need a lot of AI specific deep skills / really expensive skills to do this work, right?
Right.
Okay. Now, for some applications, retrieval-augmented generation may still not be enough, right? Of ways to adapt or customize to a specific application or provide, lots of very specialized knowledge for a particular application, right? I may in fact want to take the LLM that's been trained on general stuff or maybe partially trained in a particular domain and add very extensive training to the LLM itself, either that's unique to my organization or it's based on proprietary data that I possess, but where I want to go in and I want to, in fact, add to the training of the model, right? Yeah. And, I guess we call that fine tuning in the broadest sense, right? So, and that's certainly doable. Organizations could do that. A vendor could do that. A customer, their product could do it, or the vendor could do it to get something partly trained to their application and then work with their customers to train it with that specific customer's information, training data maybe. But that means fine tuning, and that is a technically more complex process. We are affecting the underlying model. It is a computationally much more intensive process. So anytime you start monkeying around with the training on these things, training is a very expensive, very computationally intensive. Inference, using the thing to answer questions, is also expensive, but not as expensive as training, right? So
time-wise, data-wise, expertise-wise.
Right. So there certainly are situations where we absolutely may want to fine-tune a model, which probably means, unless we're a big enough organization that we can partner with Google or OpenAI or Anthropic with them to create a fine-tuned version of their systems, which, let's face it, for most of us, that's way out of reach, right? But I could, again, start with an open source model. I could start with one of, Gemma. I could start with Llama. I could start with, again, there's lots of, I could start with an older version of one of the other models that was open sourced, and then do fine tuning. Talk to me a little bit more about fine tuning. Because this is definitely where it gets way over my head real fast when we get to fine tuning.
Yeah. So fine tune. So we said RAG, you're not affecting the LLM at all. It's kind of on its own. RAG, we're just, like as the name implies, augmenting the prompt. We're giving it more context, and we pass it along to the LLM, and the LLM is the same LLM, with or without RAG. With fine tuning, we're actually going in and internally changing the model. We're changing the weights of the model, would be the word that we would use there. And so it's going to affect how that model processes input and how it produces output. And so when you're training these models, you're showing them the training data, and so they're learning. They're learning how to, what types of responses to produce. There might be some additional steps for these large language models. You have to teach them to actually answer questions or hold a conversation, because on their own they're just going to produce text. So there's those steps, and then also deciding like what are the preferable types of responses. So that might involve somebody ranking different responses and saying this one is the best or the most appropriate, and this one's not as good. And so it's kind of the model learns those things and incorporates that into its weights.
So that process of having a human review, right? Mm-hmm. So the training isn't necessarily only an automated process, right? So when I'm fine tuning, and we read about the work that, again, OpenAI does with ChatGPT, that there's this human assisted, human in the loop aspect of training. Is that what's called what is it? Reinforcement learning with human feedback?
Human
is
feedback.
That it? RLHF, RTFM, whatever it is, RLHF.
Yeah. Yeah, so that's where, so the kind of the first steps are you show it a lot of text and it learns from that. It's a little bit different than how maybe more traditional machine learning models, they're learning from examples. So you would have data and output, data and output, data and output. These language models, usually they start with just a lot of text, and they're trying to predict. I give it the first three words of a sentence, and it's trying to predict what's the fourth word. Once it's seen those first three, and so that's where you can start with a lot of unlabeled data, and it learns those things. And the net result is you have something that can produce new words or new text, but then it needs to be honed so that it can actually answer questions well, or answer questions in a way that a human wants, and that's where that human feedback comes in.
So you mentioned unlabeled data. So that's raw data that we've got. It's raw text, or it's raw images, or it's raw whatever. So the fact that there's unlabeled data, my suspicion is that might mean there's labeled data, right?
Yeah, you can. Go ahead, John.
Oh no, go ahead. Tell me more about that, because again, this is where I kind of get a little confused.
Yeah, so when you're fine tuning, something that you can do is you can provide examples of question and response that might be specific to your domain or the problem that you're working on. So then you can fine tune these models. What I've been describing is essentially building a model from scratch. That's not what you would typically do because it's just so costly to do. But what you could do is you could take an existing model and provide it these additional examples, this additional data specific to your problem. Might be this data that is internal or proprietary, and then it can learn from that, and it will adjust its weight, or kind of adjust the way that it processes text internally based on the examples or the additional text that you've provided.
Okay. So you said this is a little different than traditional machine learning models, but we do use types of machine learning to do the training. Isn't that right?
Yes. It's the you're still using a neural network model, and it's just that the starting point, the starting data that you use looks a little bit different from what you might use with a traditional supervised learning problem.
So if I want to do fine tuning, if I want to take, again, I'll just use Llama as an example because I think it's the most widely used open source one. Mm-hmm. And they just released a new version of it a couple days ago, which got a lot of publicity. But if I want to start with Llama and then I want to tailor it to my application, let's say it's a medical diagnosis application, maybe, right, for diagnosing certain type of cancers, and we've got huge amount of clinical data on that type of cancer. Or again, there's lots and lots of examples we could use of this kind of thing. Do I have to build a unique machine learning model to do this training? Or again, are there tool sets, are there things already built or libraries I can leverage that get me some of the way there, most of the way there, right? What's involved in that? How much work is this? How much, and are there specialized skills involved in this? My understanding is there are when we get to this point.
Yes, yeah. So there are frameworks. Hugging Face, which we have mentioned several times, they have some useful libraries. The Transformers library, if you're working with language models, both for inference, producing new text, or for even potentially fine tuning these models. So those exist. So there are frameworks that can help you get started with that. In using those frameworks, though, you're going to be interacting with something like PyTorch or TensorFlow typically, and so you would need some knowledge and some skills in working with some of those neural network frameworks as well. So it definitely requires some additional expertise, more so than just using something like LangChain for retrieval-augmented generation. So knowing about training a neural network model, how PyTorch, at least to some knowledge of how PyTorch or TensorFlow work, and how to use those, and how to prepare your training data to train those models off of. Okay,
so if I want to be to tackle a fine tuning problem, I probably am going to be hiring, if I don't already have them, I probably am going to be hiring some machine learning developers, engineers, somebody who's had some training in machine learning. Maybe they've used these libraries, but at least they've done some forms of machine learning. They understand what that's all about. They've got the knowledge framework that lets them pick up TensorFlow in the event that they hadn't previously been exposed to it. But it's beyond what my normal application software engineer has probably been exposed to, even if they're a Python programmer.
That's right.
So they're going to need some of that deeper stats background to understand what needs to be done and understand the libraries, some of the techniques probably. Again, it's not that these things can't be learned, but if we're looking to get this done before we all retire, we're probably going to try to find somebody with machine learning background. The trick there is, of course, there ain't as many of those around as everybody would like.
Right.
So
right.
Now we've been teaching machine learning in our data science program since 2017. So our students are getting are definitely getting exposure to concepts of, they're getting exposed to the concept of a neural net and some of these things. We haven't been training models, so they haven't been getting that exposure. But they're getting exposure to natural language processing and some of the other concepts associated with AI and machine learning. So do those folks, do they have the foundational skill set that somebody would want to have?
They're getting some exposure to neural networks, some exposure to these Hugging Face libraries. Nowadays, if you're working with language models or NLP models, you're probably using Hugging Face for that.
Seems like, it seems like, right.
Mm-hmm.
So our grads are kind of like an LLM, but you could fine tune them to get them some more knowledge, right?
That's right. Yeah.
Yeah.
They have a good general base, and then
yeah, which is where you're going to be with lots of the folks that are out there using machine learning right now. Because lots of the people using machine learning now have been using it in other data science contexts, not training models, but they do have the foundational knowledge to pick up, PyTorch or TensorFlow or what have you. So, but fine tuning in general is going to be a more expensive process, right? Because we also are going to need domain experts, I think. The reinforcement learning part, where you're reviewing responses and saying, yeah, that's a good response or a bad response, that sort of takes people that know the problem domain, right? If I want to train something to do medical diagnosis, I better have somebody that knows if that was a good diagnosis or not, right?
Yes. Yeah. Kind of on that end, and also even on curating a training set to start with.
Right. Oh yeah, absolutely. This is a use case where you've got to be on top of that data that you're going to use to train this thing. It better be clean. You better understand the biases that are in there. And it's not that it's unbiased. All data, is my view, is biased in some way. So you just got to understand how it's biased, right? But yeah, you got to curate it. You got to clean it. You really have to be on top of that. And there's a lot of other implications about data and how do we check the consistency to make sure my model hasn't drifted as I start using it, and things like that. They're way beyond the scope of this conversation.
Yeah.
But things that we do talk a little bit about, allude to in one of the sections on our generative AI for leaders class that we're finishing up. But lots more to talk about in how to, if we're taking a model this far, we better have a really good understanding of the whole scope of responsible AI and how to use these things. Train, use, monitor these kinds of models ongoing. But technically, it definitely is possible. And so there are libraries of tools out there. I'm going to need some specialized skills. It's going to be compute intensive. So am I going to need to do fine tuning? Do I need some GPUs? Do I need one of those NVIDIA boxes with a bunch of GPUs to do this stuff?
You'll need some hardware for sure. There are methods of parameter efficient fine tuning is what they're called, where you can train these without requiring a huge number of GPUs to do it, but it's still, you wouldn't be able to train it just on a laptop, for example. So you're a lot of times you're not retraining. So these things, Llama has a 7 billion parameter version and a 70 billion parameter version, and we're not going to be necessarily retraining all of the parameters, all of the weights within that model. And so these techniques allow you to train a smaller number of weights. So it has some advantages where you can do it without requiring as heavy duty of hardware, and you get kind of a smaller resulting footprint in the end. So there's some advantages there, but yeah, hardware requirements are going to be greater for fine tuning versus a simpler system.
Now, if I want to fine tune something for a fairly narrow domain,
Mm-hmm.
I can start out with one of the even smaller open source models, something that has, weights in the millions, not billions, right? And some of these are even capable of running on a phone and stuff. So, but if I want to fine tune that, it's still going to be, relatively speaking, compute intensive. But my understanding is we're getting, again, and there's movement in the direction of having more of these that are smaller that we can tailor for certain applications, where we could use, kind of standard off the shelf hardware for those kinds of uses. At least that's my sense from some of the stuff I've been reading. Is that what you're seeing?
Yeah, I'm seeing small language models are starting to show up. So we've been talking about large language models, but there are also small language models. Orca or Phi. Microsoft has a Phi or Phi, I guess depending on how you would pronounce it, model that is a small language model, so fewer parameters, faster inference. A lot of pros there. Easier if you're starting with a smaller model, easier to fine tune or quicker to fine tune. There are some trade-offs in that the general purpose capabilities are not going to be as great on a smaller model compared to something like a GPT-4 that has a ridiculous number of parameters. So you have to kind of do the trade-offs, see, can I get away with this smaller language model? Is it capable enough for my particular problem to be able to get that savings, that efficiency boost, fewer parameters?
But this is how we constrain them. This is how we limit the impact of the negatives with how LLMs work, or control some of them. And it's part of how we're going to be thinking more broadly about what does it mean, what's an application mean, right? Because now we're going to have generative AI capabilities embedded in a lot of applications and stuff. So I guess maybe that's sort of some of my closing thoughts on this. This is another part of is I think as an organizationally about how are these things going to impact me? What skills maybe we need to create if I'm running an IT shop or a product shop. What kinds of experience do we need to be getting in using these? What experiments do we need to be running? What open source stuff can I start using? These are some of the avenues that we need to be researching. And some of these are the skills that we need to be starting to either, give our existing developers as professional development opportunities, or be looking for in the folks that we're training for the future. So I think I've just said all of my closing remarks, Michael. So what thoughts do you have to sort of wrap up what we've been talking about, or what didn't I ask you? What didn't we get to that you think's important to bring up in the context of this conversation?
Yeah, well, I think you covered a lot of it with your remarks. So I'll just say, with all things LLMs and Gen AI, just stay tuned, because these models are getting better, and so the techniques to effectively use them are probably going to continue to evolve and change. But I think you're always going to be able to benefit, through through things like RAG or fine tuning. I think even if GPT 5 comes out and is just amazing, it still doesn't have access to your your specific data or your specific use case. So I think these things are going to be, even with as large language models improve, these techniques are still going to be applicable.
Yeah. Yes. The boundaries of what we do or don't do with these techniques will change as the LLMs develop more capabilities. But yeah, we've still got the issue of it's not unique to my application, my organization. All of that's outside of the training scope for these public foundation models. So yeah, some variant of these techniques as we move forward is going to be still highly relevant. I think it's great. I think it's a great thought, Michael. I think that's a really good place to wrap this up. So, thanks for listening. Hope if you're listening to this, you're able to pick up a few things new or some pointers to some things to go dig into and learn a little bit more about. We'll be continuing this series of talks about generative AI and LLMs, digging into some other topics as we move forward. But for today, I think that's it. Say good night, Michael.
Good night.
Thanks so much for listening. You can find the links mentioned in today's podcast in the show notes below. Hear more insights like these when you visit NashvilleSoftwareSchool.com.